Welcome back everyone. In our today's discussion, we are dealing with the general torsion equation of the shaft for calculate the power of the shaft, and also we are going to calculate the torque and diameter of the shaft with the torsion equation. Let's go ahead and start with our first problem. Our problem first. A solid shaft transmits 280 kilowatt of power at 160 rpm. Determine the diameter of the shaft to transmit the required power if allowable stresses are given as 80 MPa. So what we have given in this question, we have given some data. So kindly proceed with the solution. Solution, we are given it with power 280 kilowatt and rotational speed, which is in rpm, revolutions per minute. Its value is 160 rpm, and the stresses generated is given as 80 MPa, 80 megapascal. So let's go ahead and substitute the values in the power formula, which is equals to power is equals to T into omega. As you all aware with this, power is equals to T into omega. So omega is equals to 2 pi n. Let's go ahead and substitute the values. Power is equals to 280. Power is equals to 280 kilowatts. So we have to multiply it with 1000 here. And next is 2. The value of pi is 3.14, and n, which is in revolution per minute, so we have to calculate here in Newton. So Newton is everything in the Newton is in seconds, so we have to convert the revolution per minute into seconds. So here we are dividing here with 60 for converting the minutes into the seconds, and that capital T. So we are going here to the find in first step for the capital T, because we know the for torsional equation we want to know the T, which is twisting moment or torque. So after substituting the values, we get here that capital T, which is torque, is 16719.74 Newton meter, or you can also write as 16.71 kilo Newton meter after dividing it by 1000. This is the first part we have completed. We have calculated the torque. In next part we are going to calculate the diameter of the solid shaft. In part 2, here we are using the general torsion equation for the solid shaft. It is T by J is equals to tau by R is equals to G theta by L. I have also written some of the details for you. For J is the polar moment of inertia. So here we are taking about the solid shaft, we are taking for it pi d to the power 4 divided by 32, or solid shaft also I have provided the same thing. So let's go ahead and substitute the value. Here T is equals to torque or twisting moment, which is in Newton meter. So after arranging this equation, we get tau is equals to 16T upon pi dq. Tau, which is allowable stresses, or sometimes we can also call it allowable shear stresses. So its value is given as 80 MPa megapascal. So we have to multiply with 10 to the power 6, because 1 megapascal is equals to 10 to the power 6 pascal. So 80 into 10 to the power 6 is equals to 16 T. T for torque, we have to substitute the previously calculated values of the torque, which is 16719.74 Newton meters, and divided it by pi dq, which is pi's value 3.14, and multiplied by dq. So by using a scientific calculator, we can easily calculate the value of d, which is 102.08 mm. So the formula is given us the value in meter. After calculating the meter, we have to convert it in mm. So generally we prefer the dimension in mm. So this is it for the solid shaft. uh, I am also making the same video for the hollow shaft in soon, very soon. So let's catch you later. Till then, bye bye. If you like the video, then subscribe our channel for further notifications. Thank you.